Morning.
Morning. I was actually, Professor Fox, I was wondering if I could talk to you, uh, not in class, obviously, at some other point about um, kind of what you have done as like mechanical engineering and moving forward, like into business, because that's kind of what I'm interested in, and I
Sure.
don't really have the best guidance. I was wondering if we could talk at some point.
Yeah.
Okay.
Whatever's good for you. We can do it later today during office hours if you want.
I have a class that overlaps. I take 131 and it leaves half an hour after this one.
Got it. All right. Why don't you shoot me an email of when you think you might be available? Um,
Okay.
Tuesday, Wednesday, Thursday this week are pretty good for me.
Okay.
Okay.
Thanks.
Cool. Why don't we give it another minute for people to join? All right, why don't we get started? Hopefully, a few other students will join us as we go on. How is everyone today?
Good.
Good. Awesome. Didn't sound convincing. How's everyone today?
Good.
Oh, that's much perkier and better. Thank you. Was that Audrey? Audrey Emmanuel Nicholson. Um, anyone want to, any questions before we start? If you could, so if you're on the call, can you enable your videos? And if you have your videos enabled, Xavier, if you could show us your beautiful face. I think I'm seeing your ceiling right now, maybe. Xavier? No? There he is. Woo! Cool. All right. So Homework seemed to go well. It took on average about 50 minutes. I think everyone did it that was registered for the class. So thanks for that. Again, these are the best way of practicing um, for exams and understanding materials. Your brain is a bit like a muscle, so the more you practice it, the better you're going to get, the faster you're going to get, the more efficient you're going to get at these questions, and also the better that your understanding if you see different variations of questions. We're going to continue on today with time value of money. We're going to get into some calculator functions today. Just a few updates first. So we're going to post the practice exam tonight. So there's a brief practice exam of typical questions that you will see next week. You should do those. The exam is on Monday, next Monday at 10 a.m. If you have a conflict, you should submit the form that Professor Newell is sending out, and it should be clear how to fill out that form. There will be a brief 4 to 5 question exam soft set of problems in class on Thursday. That's more to get you used to ExamSoft if you have never used ExamSoft before. Just by show of hands, can you raise your hands if you have never used ExamSoft? Okay, so there's a bunch of people. So you're going to get an email from Professor Newell. Actually, it may not be from Professor Newell. So watch out. It's probably from ExamSoft directly. You need to install it before Thursday. The download email should have come out tomorrow. Okay? Is that clear? Okay, so practice questions will be tonight. They're just a piece of paper on Questrom tools. You can do those questions independently. And then on Thursday, we'll have a brief in-class ExamSoft 4 questions, just to make sure you know how to get ExamSoft working. Okay, questions on that? You should be checking, at this point, you should check your homework scores on Questrom tools in the gradebook in Questrom tools on the left-hand side. It'll show you, hopefully, we've done one scored homework assignment, so you should see 1 point there. Right, I think pretty much everyone has done the homework, so you should all be at 1. And you should also be checking your attendance, right? I know people are still flipping sections and all that stuff, so just make sure you get credit for your attendance. All right, questions? Comments? All right, so your chat working? Okay, good. So I don't know if you know, I am a bit of an introvert, but I get really nervous on these calls when no one is actually saying anything. So could someone unmute themselves and ask a question or say hi or something? Gassam.
Yeah, I just have a question about the attendance. Where can I see the attendance?
Let me see if I can get to quickly.
Because on gradebook it just shows the homework.
Oh, it just shows the homework. Let me ask Oliver. Oliver, can you?
Yeah, attendance is under the actual attendance tab, so it's like near the bottom of the list. So it's not actually in gradebook right now.
Oh, okay, I saw it.
Cool. Thank you.
Thank you.
All right, let's get into it then. We got a fair amount of stuff to cover today, so let me share with you my screen. All right, let's go. So we're going to continue on from the last class, time value of money, yeah? Everyone see my slides? If you can nod your heads, yeah? Okay, cool. Okay, practice exam problems. So in questrom tools, there is a folder called practice exam problems. And each week there is a set of quick questions that are posted there. So these are in addition to the practice exam problems. These are every class you'll have 1 page of questions. You should be doing these every week. They're not assigned, they're not part of homework, but you should do them, right? They're best indicator of what you're going to see on the exam, okay? We will try to do them in class. Today, in today's class, I think we're chock-a-block, so we will not be probably doing any today, okay? But we will going forward. But you should check them out and make sure you're doing them. All right. So what we're going to do today is we're going to talk about multiple cash flows, and cash flows not just 1 year from now, but what if it's 20 years from now? What if it's 5 years from now? So we're going to figure out how to do that. We're going to look at our calculators. We're going to look at some of the functionality. So the calculator, hopefully you all have either this calculator or the 10B11 calculator, not the plus, or an emulator on your phone, okay? So I have an emulator on my computer. I'll share that with you as we do some of the functions. But the quicker you know how to use this calculator, the better you will be at executing and doing the exams. If you're more efficient, time will be less of a crunch for you, and therefore it takes a lot of pressure off if you're really intimate with your calculator, right? You should be carrying this around at all times. You go out for a walk, you should have your calculator. Walk the dog, bring your calculator. Go out to the beach in the Ozarks, bring your calculator. No, don't do that. All right, that's an attempt at a bit of levity, but okay, we'll try and warm up a bit. So we're going to get into the calculator. We're going to figure out present values of not just discrete cash flows. We're going to have a whole series of cash flows, and we're going to get to the IRR. We're actually probably going to do that on Thursday. Okay, so that's where we're going today. Cool, everyone all right? Okay. Quick recap of last class. Can anyone tell me what we did last class? Anything significant? If you want to take yourself off mute and just
Cost benefit analysis.
cost benefit analysis, Shelby said.
Yeah.
Okay. What's Shelby specifically? Can we say was related to that?
Being able to like convert to like the same currency and stuff, so that like, or just in general like the same unit, so that way you can compare.
Okay.
And then yeah.
Right. So we're going to compare things, and ultimately, what are we comparing? We're comparing. Sorry, see if we can get this to work. We're comparing our costs to our benefits, right? I think that's what we said. That's the two things we're comparing. And we said, well, if our benefits exceed our costs, that's a good outcome, right? And we should generally do that. And the other thing Shelby was getting at was, well, wait a second. What if the costs are over time or in different time periods? So then we said, oh, we have to bring it to the same point. And usually we say, well, the present value and the present value, okay? So once our present value of our costs are less than the present value of our benefits, we should do that project, right? Savannah, do you have a question?
No, I just raised my hands for like the recap.
Okay, all right. Do you want, okay, Savannah,
Yeah.
keep going. Anything else that you can remember?
Yeah, we learned about the present value and the future value and the equations for them.
Beautiful, all right. So we said that, okay, if I'm here, and we'll do timelines today, but if I'm here at time 0, which we call present value, and let's say this is in 1 year, we said, oh, well, what if I put $100 in the bank today? I get an interest rate, we call it I. So therefore, in year 1, I will have 100. I'll still have the $100, plus I'll have the interest, which is 100 multiplied by R. Oops, sorry. Let's call it I, be consistent. Multiplied by I, yeah? Or another way of saying it is 100 into 1 plus I. Or another way of saying it is the future value is equal to 100, or we'll say 100 is the present value, 1 plus I. Okay? So that was for a 1-year period. And if that's the case, we could also say, well, if this is true, then it's just a mathematical equation, and we could say the present value is just whatever my future value divided by 1 plus I. So we go backwards and forwards between how much money will I have in the future and how much money will I have in the present. Okay, that's pretty much what we did last class. Questions on any of that? Okay, beautiful. So why don't you do this quick question? So here we have this company. So the deal with these questions and any questions you will get in this course is there's a lot of language, right? And part of your skill that you're learning is how do you interpret the language, reject the information that is irrelevant, and use the information that is relevant, okay? So let's read it. Blue Mountain is a working farm which includes Blue Mountain Caves, an underground cheese aging facility. Yum, yum. Underground cheese. Who loves it? Not me. Blue Mountain has 400 pounds of cheese that could be sold today. Or, okay, so here's, or means I've got to make a decision, right? Or I can keep the cheese in the cave for 1 year and let it age. And if the cheese is sold today, it'll sell for $7 per pound. But if the cheese is aged in the caves for 1 year, it'll sell for 10% more. So the price will go up, right? Aged cheese is more expensive than non-aged cheese, yeah, apparently, okay? However, if you leave it in the cave, it's going to cost $200 to remove it from the caves, clear off all the cobwebs and all the gunk, and then sell it, okay? If your interest rate, right, so the interest rate you earn on your money, that interest rate I that I had on the last slide, if that is 8%, you tell me, should they sell the cheese today or age it in the caves and sell it in 1 year from now? Okay. So I don't want you just to say, oh, they should sell it today or age it, I want you to figure out how much they're going to make in profit by doing one over the other. When you finish, to put your hand in the air electronically. It's under the participant screen.
Is the 10% more per pound or is it per the bulk total of cheese?
So it just says the price goes up by 10%. So the way it works is that it doesn't matter if I take a unit price or the total price, because you're multiplying the numbers. The unit price goes up by 10%, therefore the total price goes up by 10%.
Thank you.
I think he should leave it in the cave.
Okay, just hang on a second, Savannah. Just want to see some more people put their hands in the air. If you could put your hands in the air, just to indicate that you've finished the question, that'd be great. All right, let's hey Zena. Zena, you know how to put your hands in the air electronically? It's under participants.
Okay, got it.
Okay, all right. So Zena, do you want to do this? Do you want to help me think through this? Let me frame the question on the next page, and then you can help me think through it, okay? All right, so what I do with these questions is there's a lot of English language in there, so I sort of strip it down. And it says, okay, 400 pounds of cheese today at $7 per pound. Or in 1 year, the revenues will increase by 10%. However, in 1 year, we have an extra cost of 200, okay? We need to compare the revenues today. We need to compute the revenues today and compare them to the revenues for 1 year from now, minus any expenses that we have along the way, okay? So Zena, all the numbers are on this page. What did you do?
Sorry, I'm still like learning, but
Okay.
I did the NPV equals FB over 1 plus R.
Yeah, hold on a second. Just take a step back though.
Okay.
Tina, if I sell the cheese today, how much will they get?
2,800.
Okay, so they have. You said that like a question? Is it a question or answer?
Sorry, yeah, 2,800.
2,800. Say 2,800. Damn it! It's 2,800. Yes. So for today, if they sell it today, they get 400 pounds times $7 per pound. So that's equal to 2,800. Cool. Sina, can you tell me what they would get next year if they keep it in the caves?
Sorry.
Let's start by saying how much cheese will they have next year in pounds? Still have 400. Yeah, beautiful. And then what's the price next year?
770.
Okay, so it's $7 multiplied by, here's the way I do it, 1.1, right? Yeah, I multiply it by 1.1. I get 110%. The way
Yes.
Zena did it all in one step, but she said, oh, 10% of $7 is 70 cents. So in total, it's $7.70. Okay. Did you multiply that out, Zena?
Yes.
What'd you get?
3,080.
3,080. Beautiful. Okay. So far, so good. But if I keep it in the caves next year, Zena, this will be the last question, and then I'll let you go. You've done well. If we keep it in the caves next year, what else is going to happen?
We're gonna have to subtract 200 since it costs 200.
Beautiful. All right. So therefore, I really end up with 2,880. Yeah. Oops. Is that right?
Yeah.
Okay. All right. So now I can compare. Maybe can I compare? And I could say, no, Eliza's going, no, I can't compare. Right. So before we do time value of money, we'd say, oh, 2,880. That's more than 2,800. I should keep it in the caves. Eliza, you're shaking your head saying, no, we shouldn't do that. Okay.
Put it in the same time frame, so you either have to discount the amount that you're going to get 1 year from now, or add interest to the one that you calculated for today.
Okay. Which one did you do?
I mean, I did both just to double check. But...
Oh, that's so hot. Awesome. Okay.
I guess like the first thing you could do is just discount the one from 1 year today.
Okay. So let's get the present value. So this is what Zena was saying. She was like, well, I'm going to take the future value and divide it by, okay? Okay. So what did you do? Just call out the numbers, Eliza?
So it's just 2,880 divided by 1.08.
1 plus 0.08. Are you sure it's 0.08? Why isn't it 10%?
Because the interest is 8%.
That's right. Say
Yeah.
Say it forcefully. The interest is 8%. It's
Interest is 8%.
the price grows at 10%. That has nothing to do with the time value of money. Well, it has something to do, but it's not relevant, right? We're interested in the time value of money, therefore we use interest rates, not the growth rate of prices. That's different, okay? So beautiful. And then you got, what did you get for that?
And then I got, so I got 2,666 and 67 cents.
Okay. Thank you. Savannah, where's Savannah? Sorry. Was Savannah that had an answer earlier on?
Oh, yeah, I did not do the last part correct.
Okay. Okay, never mind. So do you want it? Okay. Okay, with the information you have now, can you tell us what should we do?
Well, now we can compare the 2,666.67 with the 2,800, and we just compare the cost and benefits, and it just shows that 2,800 is more. So keeping it in the cave would be more beneficial.
Okay, you lost me at the very end. You
Okay.
said you teed it up perfectly. You said, if I sell the cheese today, I get $2,800.
Yes.
If I keep the cheese in the cave for 1 year, I get the equivalent of $2,666 today.
Yes. I mean, we could take the, well, since we put it into present value, we don't need to take it into future value anymore. So we can just compare the two present
All right.
values.
So I'm going to compare these two things in the boxes. Which one
Yes.
would you prefer? If I'm giving you money, which one do you prefer?
2,800.
Okay. So you
I have a
prefer
question.
2,000. Goal, you've got a question?
Yeah, what if we sell it today and save it in a bank and then add the interest rate to it?
In a van.
No, what if we sell it today and save it, deposit it in a bank and add the interest rate to it after 1 year?
Yeah, okay, just hold on a second. We'll do that. Yes, we'll do that. Savannah, okay, so you said you prefer 2,800, right? So that's saying you should sell the cheese today
Yes.
because 2,800 is greater than 2,667.
Yes.
Because if you keep it in the cave for 1 year, you get the equivalent of $2,667 today. Okay, so which one do you prefer again, Savannah?
Today.
Okay, all right. I don't think that's what you said originally.
Yeah, that's because I did the last problem wrong.
Okay, that's okay. All right, so you want to sell the cheese today. Joel, how do you think about it?
Okay, yeah, so I didn't calculate the present value. I instead calculated, I took the amount I get today, the revenue I get today, I converted that to a future value, and that I got 3,024, which is greater than
Okay,
2,080.
Okay, so you said, I take my 2,800, I put it in the bank, I think you said, which is exactly the right concept. So I got 1 plus the interest rate, and so that's equal to 2,800 multiplied by 1.1. So you got, what was that?
3,024.
3,024, okay? And then you compared that to which number?
To the 2,880.
Right, so you said, okay, I'm going to compare. If I just sell it now and put my money in the bank, at the end of a year, I will have 3,024. On the other hand, if I keep the cheese in the cave, I will have 2,880 in the future. So which one do you prefer, Goal?
I would sell it today.
I will sell it today. Okay, so no matter whether you look at it in the future or the present, you're going to come up with the same answer, right?
Yeah.
Perfect. Okay, is that clear to everyone? Nice. Okay. Can I move on? Okay. Once I leave this page, I'm going to lose all my annotations, I think. Oh no, it's still there. Cool. All right, so that's how you do it, and you could say this decision is sell today, and the present value, you're better off by $133 by selling it today. And here, to get that 133, all we did was subtract these two numbers. Okay. Okay. Timelines. Let's talk about timelines. So a great way to represent any of these problems is using a timeline. So a timeline is just simply the graphical representation of where the cash flows occur. Okay, so you can see on this screen, here's today. So timelines usually start at time 0, which is today. And then you have 1 period from now and 2 periods from now. And the convention is that this is end of year, right? So this would be December 31st of last year. This would be December 31st of this year. And then this is December 31st of next year, okay? If these are annual numbers. Okay, so this is a span of 12 months in this situation. And we show here's a cash flow of 10 grand, and here's a cash flow of 10 grand. And here's a cash flow of $0, right? So when I put in 0, that's relevant as well. That's important to know as well. Okay, so by drawing things on a timeline, you can see graphically when you're going to get the cash flows. And sometimes we'll actually have multiple cash flows. So let's say in year 2, I had $2,000 as well. Well, then I could just add those, right? So it's an easy way of just representing your cash flows. You might think it's kind of goofy, but let me tell you, for each of my questions, when I do them for the first time, I will draw a timeline. So as you go through your homeworks, you should get into the habit of drawing timelines. As you do these practice questions, you should do timelines. As you do your exam, you should do timelines. Have a scratch paper and just do a quick timeline. And it'll sort of show, oh, that's where that cash flow is, right? Okay. And then we can show different cash flows. Sometimes they're negative, sometimes they're positive, right? Usually for most projects, you'll have a negative outflow at the start, right? So you'll show that as a minus. And then you'll have an inflow, we show that as positive, show that as a positive, right? So your conventions are important. Usually the way I think about it is if money is leaving my wallet, that's a frowny face, right? That's a negative, right? So that's a negative to me. But if money is coming into my wallet, that's a positive, right? So just think about that sort of simplistically. All right. Here we've shown years, but we'll see later on, well, maybe years a long time, right? Someone take themselves off mute and answer this. How frequently would you pay your loan if you had a car loan, let's say?
Monthly?
Okay, someone shouted out monthly, right? Does everyone agree? When you have a student loan and you're going to go into the repayment period, you're going to pay that monthly. Maybe people are saying, oh, I don't have a loan, or I don't have a car, I don't have a car loan, or I don't have a credit card. Let me ask you, do you have a freaking cell phone, baby? Yeah, you all have cell phones. When do you pay your cell phone bill? Every month, right? I think universally everyone pays them every month. Or maybe if you're lucky, maybe a parent might pay for it. But they pay every month, right? So this timeline will now, instead of it being annual, we'll convert the timeline to months, right? And we'll have a trick that'll do that for us in a few classes where we can get a monthly interest rate, and then we can use months to do these calculations, okay? All right, everyone okay with timelines? We're going to use them. I really want I want to see you write down the timelines. I'll ask you from time to time to hold up your piece of paper to the screen. Look, this is an old piece of paper. I've done other calculations, but look, I've drawn a timeline on this, all right? So I want to see this timeline. Okay, let's move on.
Wait, I have a question.
Yes, sir. Who's that?
Josh.
Hey, Josh.
So
From Cornell, baby.
Yeah, the money represented in the timeline isn't present value, right? It's
it's
the
not.
value in each year. Okay.
Right, it's just the absolute amount of dollars in each year. And that's what we're
Okay.
trying to show is how are those dollars dispersed over time? We're going to get them back to present value, but how do they look in
Okay.
reality, in the physical world? Okay, good question. Thanks. Okay, so to help us do all these, we've got three rules of time value of money. The first rule is when we compare and combine values, we have to do them at the same point in time. Okay, so it's only possible to compare or combine values at the same point in time. All right, that means if I want to compare dollars in a year from now, I have to get it to the present value and compare it to the present value. Or I can move everything to the future value and compare it to the future value, right? That's what we did on the cheese case in the last case. Goal looked at it in the future value basis. That was appropriate. And Eliza looked at it on a present value basis. That was entirely appropriate as well, okay? Second rule is if we want to calculate the cash flow's future value, you must compound it, okay? We're just putting the language on it now. So when you grow things in the future, it's a special name, it's called compounding, okay? So in order to do that, here's an example. If I have $1,000 and I want to grow it for 2 years, I multiply it by 1 plus the interest rate, which is 10%, gives me 1,100. Then I get that 1,100, grow it by 1.1 again, and that gives me 1,210. And you can do that for however many times you have years. So if you did that mathematically, you would say the future value is just C is the cash flow. So in this case, it's 1,000, the initial cash flow. And then you multiply it by 1 plus the interest rate, and multiply it by 1 plus the interest rate again, and multiply it by 1 plus the interest rate, and so on and so forth. Or to abbreviate that in math, we would say it's C multiplied by 1 plus R, raise it to the nth power. R is the interest rate, and N is the number of years, i.e. the number of times you're compounding it. All right, everyone okay with that? Okay, so that's the first formula, right? That's just exactly the same as what I had on the very first page, except now we're putting in multiple years. So therefore, I just raise it to the power of N to compound it for N periods. All right? And if I do that, look at this, this graph is interesting. Here's the example with $1,000, that's how much I put in the bank to begin with, right? So this red bar is $1,000, right? Everyone see my cursor when I drag my cursor along? Yeah. So that's my $1,000. The green bar is actually 10% of $1,000. It's $100, right? So in the first period at time 0, I have nothing, but then after year 1, I have $100, right? That's my interest, right? So I add it to the 1,000. That's what I would have after 1 year. Okay, so this is cumulative. After 2 years, I'd still have the $1,000. Now I'd have $200 worth of interest, right? Because it's $100 each year. So that green bar is now 200. But in addition, I would also get a little bit of interest on the interest, right? So it's actually 10% of $100 is $10, right? That's why we go back to this. In year 2, I didn't have $1,200, I had $1,210, right? The reason for the extra $10 is because the interest here made interest, so I had interest on the interest. Is that clear to everyone? Okay, so that's the power of compounding. So if we drew this out for multiple years, you could see this is the way the graph looks like. I've got interest and interest, which is the blue bar. The simple interest, which is $100 per period. Cumulative, this is what I would have over 20 years. 20 times 100 is $2,000. So I would have $2,000 here, okay? All right, by power of observation. What do you notice about this graph? Kate, you had your hand in the air. Was that just a leftover?
Yeah, I think I just
Okay.
again.
Xavier, do you have a question? Or Josh, do you have a question? Okay, so if you could take your hands down, Damien, just so I can see. Okay, thanks. All right, by powers of observation, what can we say? Someone want to unmute themselves and say something?
It's increasing exponentially at like the same rate.
Okay, Shelby is saying it's increasing exponentially, the total curve. Yeah, it's going up exponentially. Jan Hu, do you have a question or an observation? Yeah, you have your hand in the air, Jan Hu.
No.
Okay. All right. Can anyone tell me, Jan Hu, can you put your hand up?
Oh, okay.
Thanks. Okay. Can anyone tell me which bar is the biggest bar? What color is the biggest color? Yeah, Cassie, come on, Cassie, baby.
The
From
interest
Kerry,
on
come on, from
interest.
Kerry. Woo!
Interest on interest is the biggest bar.
The blue bar is the biggest bar. Yeah, look at that.
Yeah.
All right. So this shows the power of compounding. So can you give a so what that's the biggest bar, Cassie?
Well, if you hadn't put your money in the bank, then you would have had just like the small red bar, but because you did, you earned extra money off of the money that you had put in.
Okay.
Basically.
Okay. And can you relate that to your life? What should you do potentially? What meaning might this graph have for you in your life?
Just put money in the bank in my life.
Save early, baby. Save early. Do we agree with that? You can disagree. There's certain people that say you should spend everything that you have. There are other people that say if you save a little over time, it's not the idea of the red bar, how much you're saving. It's not even the idea of the green bar, what's your simple interest. It's the compounding power. That's your real power, right? Okay, so let compounding be your friend. And if you put money to work early, it should give you big results because of compounding, because of interest on interest, right? Everyone clear on that? One semester I had someone who was a bit more philosophical about this graph. And they were reading a lot into it. It's like, wow, I didn't read that into it. But here's what they said. Professor, this is why we have the 99 percenters and the 1 percenters. Does everyone know what the 1 percenters are? The 99 percenters? I was like, what do you mean? What do you mean? And the student, I think quite astutely said, this is why the rich keep getting richer and the poor keep getting poorer. Okay? So think about it. If you have money and you have the ability to put your money aside to save it and not spend it, you get this graph, right? You have the ability to have compounding. However, if you're not rich and you don't have money that you can save, you don't get this compounding effect. Actually, you get the inverse of it, right? If you borrow money, you're actually paying interest on the interest. That's the problem with credit cards, right? So you actually never get the ability to save money because you're always behind the curve. I think that's actually, if you think what's going on right now in our society, the people who were living paycheck to paycheck have now run out of paychecks because they're not getting paychecks. Maybe they're getting some unemployment assistance. So they're really struggling, right? Because they don't have the power of compounding. They haven't had the ability to save anything, right? Okay, I'll move on. That was too deep for finance. Okay, let's go. So that's rule 2. Rule 3, so rule 2 was compounding. Rule 3 is discounting, okay? So rather than going forward, if I want to come back, we call that discounting. So in order to do discounting, I'll take my 1,000 divided by 1 plus the interest rate, divided by 1 plus the interest rate successively. So if we did that mathematically, the present value is C. C is just the cash flow, the $1,000, divided by 1 plus the interest rate and raise it to the power of n, where n is the number of periods you're discounting by. Okay, it's just exactly the opposite of the last equation. Is the last equation just rewritten? Okay, so there are the 3 rules. In order to value things, you have to be at the same point in time. In order to grow things, you have to compound them. And in order to bring things back to the present value, you have to discount it. They're the 3 rules. Okay, let's move on. And then note the relationship. Here, if I discount this $1,000, I end up with 826. But if I compound that 826 by the same interest rate, I get exactly back to the 1,000. You have to, it's math, right? It's like multiplying and dividing. All right. Okay. Let's do this example. Let's read this. You're considering investing in a savings bond that'll pay $15,000 in 10 years, in 10 years' time. Okay, there's nothing before 10 years, right? It only happens at 10 years. If the interest rate today is 6%, what is the bond worth today? Okay, I love this question. Let me ask maybe a personal question of you all. Who all here has their favorite aunt or uncle that have given them a savings bond? Come on, there's 1 or 2 every class. Particularly in the US, but it also applies overseas. In Europe, they have government bonds and savings bonds. No? Anyone? Anyone? Okay, let me show you what I'm talking about. This is a savings bond. It's my, let me go back so I can see myself. It's my son's, right? Can everyone read that? Is that the right? No, is it reversed? Okay, it's called the Patriot Bond. Alex is my son's name, just in case, you know. I have a post-it over here to protect the innocent, all right? Okay, has anyone got one of these? Come on, someone must have it from their favorite aunt or uncle. No, grandfather, grandmother, no. Forget it then. Okay, why don't you do the math then? Audrey, do you have one? Audrey?
I do, yes.
Wait a second. Dude, you're holding out for me.
I don't have the paper bond, though. I have no idea where that is.
Oh,
but I
okay.
do know that it exists somewhere.
Okay, and who did you get it from?
My grandmother.
Oh, Granny. Awesome. And is it for like $100?
Something like that. Yeah, I think so.
Or more? Maybe. Is it for $15,000?
I don't think it's more.
$15,000, Audrey. What a nice granny you have. Okay.
Yeah, this is me in 10 years.
Okay, let's go. Here's what I want you to do. I want you to figure out, what is that worth today, that $15,000 in 10 years? What is it worth today? I.e., what is the present value of that today? So you're going to need your calculators to do this. That's it, Cassie. Reach for that calculator. Damien, you got a question or you got an answer?
An answer.
Okay, just hold on a second. Let people do this calculation. Okay, again, if you finished, just put your hand in the air electronically. Okay, cool. All right, we're nearly there. Queena. Hello.
Yeah. Hi.
Hi, can you tell me what you did?
I'm not sure whether my answer is correct. I got
What did you do, Queena? Just tell me the steps of what you did.
sorry, I didn't receive my calculator yet, so I was trying to do that like online, but I just couldn't find that website. I can I give you the equation that I have, like how I.
Okay, can you give me the equation?
I do 15,000 divided by 1 plus 0.06 and to the power of 10. Is that?
Beautiful. Everyone agree with Queena? Right, you get the present value to do that, right? And Queena, did you were you able to do that?
Yeah.
What'd you get?
Is 8,375.92.
0.92. All right. Everyone okay with that? That's what I got. Does anyone want me to do it on the calculator? Let me show you how. Actually, I won't even ask the question. Let me show you how to do it on our calculator. If I can do this. This might screw us up, but here. Let me share it. Can everyone see the calculator now on my screen? Yep. Okay. So here's the way you do it. I always start with the denominator. So 1.06. And I need to raise that to the power of 10. So you can see here under the multiplication key, it says y to the power of x in yellow, right? So whenever there's a yellow thing on your calculator, it means you have to use the yellow shift button. Okay, so I'm going to do yellow shift y to the x, and you can see on the screen it says pending. It's waiting for me to tell me what's the exponent. The exponent is 10 years. And then I press enter. Okay, so what that says is 1.06 raised to the power of 10 is equal to 1.79. Okay, that's the denominator. Rather than re-entering numbers, here's what I do. I take the inverse of that. So you see here on the division sign, it says 1 over x. So that gives me the reciprocal. So I just do shift 1 over x. That's 0.56. So now what I've achieved is I've taken 1.79 and take 1 divided by 1.79. That gives me 0.56. Multiply it by 15,000. And that gives me 8,375.92. Is everyone cool with that? Okay, so the point is, on your calculator, this y to the x, you're going to need to know that. Okay, everyone cool with that? Questions on that? Okay, everyone see, back to the slides. Can everyone see my slide deck again? No?
Sorry, Professor, I actually have a question.
Yeah.
So I actually took 15,000 divided by 1.79, and
Yep.
that gave me, no, it gives me 8,379.89.
Yep.
So like there's like a tiny bit of difference, whether
Yeah.
if you like times it by 0.56 or like divide it by
Yeah.
1.79. Like, does that really matter on the test whether we, get which side of the answer?
No, doesn't really matter. Okay, so I'm going to recommend a number of decimal places that you set your calculator to. And if you set it to that, if you set it to 4 decimal places, and just keep everything to 4 decimal places. But again, I try not to re-enter numbers. And 4 decimal places will give you plenty of specificity. It'll give you what you need, okay?
Got it, thank you.
All right, so let me go and share this again. Okay, can you see my screen now? PowerPoint? Yeah, okay. Whew. All right, good. All right, so let me go back then. So we got this bond that's going to pay 15,000 in the future. It's called a savings bond. And Audrey, where are you gone? There's Audrey. Okay, Audrey, your grandmother, you love her deeply. And you felt so awesome when she gave you $15,000 of a bond. Audrey, actually, how much did your grandmother actually pay for the bond?
8,375.
What? The cheapskate. Yeah. Okay, so the idea is the present value today is a lot less than the future value, right? So, so this difference between the 8,000 and the 15,000, that's just the time value of money, right? And so that's why savings bonds are popular, because you get to buy something that's worth, in this case, in my kid's case, you know, it's worth, wait, sorry. I can't see myself, so therefore you guys can't see. So its face value is $100, right? So it looks like it's worth $100, but chances are I paid a lot less for this. Actually, I paid $100 for this, but it is going to be worth more. Actually, I didn't pay for it. His grandmother paid for it, oddly enough. Okay, let's move on. So that's what we have on the timeline. Again, I would draw the timeline. And this one, it's kind of simple. There's only one cash flow at the end, it's 15,000, and that's the math. Okay. I'm going to skip over this. Here's just another example. If this company, it's expecting to get a cash flow of $2 million in 5 years from now. But if the competitive interest rates are 4 years per now, 4% per year, sorry, how much can they borrow today so that they can pay it back entirely with the 2 million? Here's what we said last class is sometimes I need the money today, right? And I can use interest rates to let me move money backwards and forwards in time. So 2 million 5 years from now, yeah, that's nice, but I really want the money today. So therefore, the way you do that is you take a loan, get the money today, and then pay it back with the 2 million 4 years from now. So how much can they borrow today in order to pay off with their 2 million? So the timeline would look like this. The math would look like 2,000 divided by 1.04, because 4% is the interest rate, and then raise that to the power of 5. So it says I can borrow 1.6 million today, and I know that I can pay it back with my 2 million when I get that 5 years from now. Right? Everyone cool with that? Okay. Gee, all that exponent, Professor, that you told us about, you know, raising it to the power of 10, that took a lot of work, didn't it? My fingers are tired now crunching on my calculator. Is there a better way to do it? Oh, good question. Yes, there is a better way to do it. And it's what I call the top row of our calculator, right? So the top row, the reason we get you these, we have you buy these calculators, these are financial calculators, and they're programmed for this type of calculation. It's actually programmed, it's actually a bond calculator. So we'll do bonds in the second half of the course. But the top row is basically a bond calculator, but it allows us to do these calculations. So let's talk about some functions on my calculator. I'm going to do this on the real calculator, on the emulator, so you'll see what I'm doing. We'll do this and then we'll take like a 10-minute break. Is everyone okay? Okay. Okay. Where's my calculator? Hey, everyone see my calculator? So the first thing you want to make sure is between calculations, you want to clear the registers, make sure nothing is left over. So the way you do that is you do, see this see all, clear all, you want to do that. So you do the yellow button and shift clear all, and it clears everything, right? So now nothing's in memory, nothing's in the time value of money. Notice when I do that, clear all, you know, you guys should be doing this along with me. So do shift clear all. Notice anything that flashes up on your calculator? Thanks, Cassie. You're playing along here. Cassie, what did you notice?
My calculator says 1p year.
1p year. That's good. Okay, we're going to leave yours alone. Mine says something different. Anyone else got something different on their calculator? No, Julia, you got 1, do you?
Yes, I do.
Anyone got anything other than 1?
Mine is 12 payments
Who's
per
that?
year.
Who's that?
Audrey.
Audrey. It's 12, right? Just like mine, right? So that's what that's going to do is it's actually going to compound it 12 times per year. Which, okay, if you're doing months, that's good. But if you're doing Finance 101, that's bad because you're never going to get the right answer. So we want to make sure your calculator is set to 1 compounding period per year or per period, right? So we want to set that to 1. So here's the way you do it. So you see up here on the top row of my calculator in yellow, it says P per year. That says periods per year. So I want to set that to 1. So the way I do it is I press 1 and I press Shift P per year. Okay, please do this, all of you as well. Audrey, did you do that, Audrey? Audrey looks like she's frozen. So, and then, so it should be set for 1. The way you verify that it's set to 1, now do clear all. And if you do clear all, it says 1p per year. Audrey, did that work for you? Okay. So now hopefully everyone has their calculator set to 1 compounding period per period. Yep. Oops. What the heck happened? My calculator just disappeared. Where'd my calculator go? Sorry, I'm gonna have to stop sharing. Find my calculator. Okay. All right, everyone see my calculator again? Okay. All right, the next thing I want to do, so now we've set our compounding periods to 1. Someone asked me about, was it you that asked me about my rounding? So I want to set my rounding, right? So I want to set it to 4 decimal places. Here's how I do that. You see in the equals sign, it says display in yellow, right? So that's going to set my display to whatever number digits I want. So I want to say shift display, and I want to set that for 4 decimal places. So the order is shift display and then your number of decimals. So I want 4 decimal places, right? Everyone cool with that? So once you have it set for 4 decimal places, leave it at that and you should be set for the semester. Everyone cool? And then the last thing is if you have a comma instead of a decimal place, if you're from Europe and you use commas instead of decimal places, you're very Parisian where we use commas instead of decimal places. Sorry, bad French accent. Don't do that. We'll just use this key under the decimal point toggles between commas and decimals, okay? If your calculator is set that way. All right. Everyone cool? Last thing we want to do is the top row of my calculator. Well, what I wanted, the time value of money keys. Okay, let's go through it. N, what do we think N stands for? If you could take yourself off mute and yell out an answer. Kelly, what is N?
Oh, which one were you asking for?
Kelly, Lou, what's N?
N just stands for like the number of years or months.
Right, so the number of periods, that's perfect. Most people say, oh, it's the number of years, but you're correct, Kelly. Technically it's the number of periods. So N is the number of periods. Cool. All right, so in those other questions, you know what I had that bond for 10 years? N would be 10, okay? I per year, what do we got there? Damien, what's?
Interest per year.
Right, so the interest rate per year. Here's the trick with HP calculators. They're not familiar with decimals, right? So when you put in interest rates, you have to put it in as a percentage, okay? So if I'm putting in 4%, I type in 4, that's 4%, and I press interest rate. If I typed in 0.04 as the interest rate, that's saying it's 400th of 1%. That's going to be the wrong number. So remember, these are always in percentages. So put in 4, that's 4%, okay? Beautiful. PV. What do we think PV is? Grace.
Present value.
Present value. Beautiful. All right. So PV is present value. That's pretty intuitive. Cool. Grace, that was an easy one. So I'm going to give you the next one. What is FV?
Future value.
Future value, right? So now future value, present value, right? If I want to toggle between the two, I can just click on those, okay? So let's say interest rate was 4%. Let me give 5 years, and I have $15,000, let's say, as my future value. I press FV, and then if I want to get the present value, all I do is I press PV, and it'll say, oh, there's your present value, 12,328, okay? Kelly, you've got a question? Kelly Lou, you got a question? No, you got your hands in the air? Okay. All right, everyone okay with that? The last key, oh, I skipped over this PMT. Anyone want to tell me what PMT is? We haven't really talked about it yet, but.
Payments made.
Okay, I think Gasson was first to the mute button. What's that?
Yeah, it's payment.
It's payment, yeah, explain what that is.
So if there's like a recurring cash flow every year, you would just use that to indicate that that's the payment every year.
Right, so we have sort of future value and present value. What if I had payments in between? Well, those PMTs, we call them PMTs, payments, so that the calculator will adjust for that, right? But they have to be the same number each and every year if you're using the top row of your calculator, okay? Everyone cool with that? Okay, so let's just do the last problem. I want you guys to do the last problem. So it was $2 million. Okay, well, let me switch back to the slide deck. Okay, can everyone see my presentation now? Okay. Okay, so I went through those slides. Okay, so what's the present value of 2 million in 5 years if the competitive interest rate is fixed at 4% per year? Okay, so I want you to do that. 5 is the number of years, 4 is the interest rate, 2 million is the future value. You can enter 0 for the payment, so 0 and PMT. The default is 0, so you don't actually need to do that every time. And then press your present value. let's see, who hasn't? Tiffany. Did you put your guess, Tiffany?
Yeah,
What you get?
I got, oh wait, -1643854.21.
Beautiful. All right, so these are the inputs. So when we do these calculations, we sort of represent it. These are the inputs on this given line. And then the output is this, okay? And notice that it's the opposite sign, Tiffany, right? You said it correctly. It says minus, right?
Yeah.
And here's the point is, if I'm getting 2,000 in the future, it's like I have to invest 1.6 today, right? So that's a minus. Whenever I invest something, it's going to be a minus because it's money coming out of my wallet. But then I'll get the return 5 years from now, and it gives me a positive of 2 million. All right, everyone okay with that? Okay. Why don't we take a 10-minute break, come back at 24 after the hour, and then we'll have a drill to do, just get you to practice on using this time value functions, okay? 10 minutes, get up, walk around, get a cup of joe, cup of water, do some exercise, do some push-ups, call your grandmother, drive your Shelbys. Okay, let's get back. You can turn back your videos, turn your videos back on. It'd be great. Tiffany, what time is it there?
It's like 11:30 p.m.
Yeah, are you getting tired?
A little bit.
A little bit. You're getting a little bit tired of finance, are you really?
Because I have another class at 6 a.m. tomorrow morning.
What's that? SM 131?
Now it's CM 331. It's a con class, a writing class. Yeah.
Ooh, that seems hard to me.
No.
All right. Can you guys turn your videos back on? Xavier, are you back? No. Kelly? Goyle? Alex Wen? Can you turn it back on? Okay. Xavier's not. Okay. All right. Everyone see my screen, my PowerPoint presentation again? Yeah. Okay. Cool. All right. Here's what I want to do. So over the next 20 minutes, we're going to do a lot of exercises to figure this stuff out. So let's all start with this one. By the way, does anyone not have access to financial calculator at this point? If you could raise your hands or let me know. So I said before, if you don't have the calculator, you can buy an emulator on your iPhone, or I'm sure on any Android device. You can buy it from the App Store. But just make sure you get the HP version, right? Okay, here's what I want you to do. Let's take a couple of minutes and let's do this. I want you to calculate the present value. By the way, actually, if you don't have the calculator, there is the emulator that I'm using. I just saved it on Questrom Tools in the folder, so you can launch that if you want from your computers. All right, calculate the present value of $1,000 in each of these situations. 5 years from now with an interest rate of 8%, 10 years from now with an interest rate of 8%, and then 10 years from now with an interest rate of 4%. Okay? Go, you guys do it. When you're done, please put your hand in the air so we can make sure we keep this class moving. Okay.
John?
Yes.
I don't know. I'm following the instructions, but when I press PV, it just shows me like the last digits I put in.
Say that again, Savannah?
So like I follow the instructions and I put a number and then I press the unit that it's supposed to go in, like N or FV. But when I finally need the present value and I press PV, it just shows me what I last put in digits wise.
Okay. That sounds strange.
Mm.
All right. Let's do one together, Savannah.
Okay.
I'll share the calculator with you.
Thank you.
And you tell me what to do, okay?
Okay.
Okay, you see the calculator?
Mm-hmm.
Okay, so here's what I'm going to do. Clear all first, okay?
Yeah.
Okay. Now tell me, first question.
Mm-hmm.
What's the first thing you put in?
I put 5 years, 5, and then I press N.
5 and then N, okay?
Yes.
And then when it adds on the decimal digits, you know that it's registered that in the calculator.
Sorry?
When it adds on, you put in 5, but when it registers it, you can see it says 5.0000.
Yes, mine says N equals to 5.000.
Okay, so that's a Texas Instrument calculator.
Yes. Oh, it was the only one available.
On what? Online?
I went to get it from Staples.
Okay, did you wear a mask?
Yes.
Sorry, I'm just having jokes between myself and my brain. It's so funny. Yeah. So if you can, I would go back and just bring it back and get your money back and tell them you got the wrong version. And get it online at Amazon if you can.
So it's not working because it's a Texas Instrument.
Yeah. Don't mess with Texas, right, Xavier? Xavier, you're from Texas, right? Victoria's from Texas. Okay. It's loud in there, Savannah. So I'm not sure how the Texas Instruments calculator works.
Oh, so it's a little different. Okay, then I'll
It's a little different.
Okay.
Okay. Okay, so keep going. It's 5 years. Then what?
Okay, then put 1,000 in for FV.
Okay, so 1,000 FV. Then what?
And then 8 for I over YR.
Yep. So I put in 8, and again it's 8%. So I don't put 0.08. I put in 8%.
Yeah.
And then I want to get.
Yeah.
And then I on my calculator I just press PV, and it tells me it's $608.58. Okay. It still didn't work on your calculator, Savannah, did it?
No. But, yeah, no.
I'm sorry. I don't know how to tell you how to use it. I don't know. Okay. If you go to Questrom Tools, and you can download the emulator from Questrom Tools. Okay, and so it'll work on your screen just like mine's working on my screen. Okay. All right. Who's got the next answer then? Damien, what you got?
I got 463.19.
Okay. And how did you calculate that? Did you use the top row?
Yeah, I used the top row.
Okay. Grace Handler, what you got? That's a delicious looking. Is that a smoothie?
Yes,
Yum. Where'd you get that? Starbucks?
I made it.
Good. Don't go out to Starbucks. Okay. What you get for the next one, Grace?
For the one with N10 and IR or interest rate for.
Yeah.
I got $675.56.
Beautiful. Thank you. Okay, everyone okay with that? Any questions on that? Okay, so there are the answers. Okay. Here, let's keep going on this drill. Now let's go backwards. If I have $1,000 as present value, what's the future value going to be in 5 years with an interest rate of 6%, 10 years at 6%, 10 years at 2%? Okay. So part of this drill is not just trying to get the answer, it's trying to get you to use your calculator efficiently and with confidence. Okay, let's go to it. Let's do it. Niharika. Did I pronounce your name correctly?
Yeah, it's Niharika.
Niharika, sorry.
Yeah.
Niharika, you want to tell me the first one? What you get?
So the first one is 1,338 and 23 cents.
What did you use? The top row of your calculator or the formula?
I use a top row.
Okay, good. So as we go forward, I really want you guys to be using the top row of the calculator. You could compound this and use the formula, but I prefer if you use the top row. Okay, Alex, under when?
Yes.
How you doing?
I'm alright.
Okay, can you answer the next question, please?
Sure.
Are you just doing it now, Alex?
No, I didn't write it down. Sorry. So the future value would be.
Well, if you never wrote it down, like if a tree falls in the forest, did it really fall? Just kidding. It's a little bad joke. Alex, you gotta write it down, baby. How are we gonna know? How are you gonna learn?
Sorry.
Okay, what you got?
I got 1,790 and 85 cents.
Beautiful, cool. Okay, next, Alex. Kreidler. Alexandra, sorry.
Yeah, I
Do you
got.
go by Alex or Alexandra?
I go by Allie, actually.
Hey, Ali B. Okay.
Yes. I got 1,218.99.
Great. Thank you. Everyone okay with that? Okay.
Actually, I have a question.
Yeah, who's got a question?
Tiffany.
Tiffany, sorry, can't see
Yeah.
you. Let me go
So
back.
when I type the number into the calculate and it come out with negative number, I just wondering, is there any mean by the negative or just?
So again, the convention that Hewlett Packard has used is that one of your cash flows, at least one of your cash flows, has to be negative, right? And the idea is when you make an investment, right, you have to give money, you have to invest money, right? And that tends to be a negative, right? When you do the first investment. But then when you get the money back, that's a positive, right? So HP is showing that. So in these cases where you got a negative number, you only got a negative number because you put a positive number in, okay?
Okay.
So in some of the questions, it will be important. It'll say you spent money or you invested money, and then you invested more money, and so therefore it's important that you keep those as negatives, and then anything you get back is a positive, right? Okay. So it'll become more obvious on the negative and positive, but for the moment, it doesn't really matter, right? We're more interested in the absolute number.
Okay, thank you.
Okay, cool. All right, so then, so I want to go back to Ali B. Sorry, I'm using your middle initial. So what did you, when it talks about, what do you observe by the impact of time and interest rates on future value, Ali?
For future value, it seems that when there's like more time has like elapsed, the future value will be higher with the same interest rate. But if it's like the same amount of time but a different interest rate, with the higher interest rate, you will still have more money in the future.
Beautiful. All right, so you got it, right? So the implication is if you leave your money in the bank for a longer time, all other things being equal, you will have a higher future value in the future. Similarly, if you leave your money in the bank for a given time and one bank has a higher interest rate, you will have a higher future value with that higher interest rate. That's the implication, right? And it always is easier for me to understand what the implication is for future value. When it talks about present value, the impact on the present value is the opposite, right? As my interest rate goes up, my present value goes down. That's because I'm discounting it, right? And the longer it is between the future value and the present value will also go down. Okay, the more you discount it, the more it'll go down. All right, everyone okay with that? Okay. All right, here's what I want to do now is I'm going to break you into breakout rooms. There should be about 4 of you in each room, and here's what I want you guys to do. The first thing I want you to do is I want you to talk to each other. If I go into your breakout room and you're not talking with each other, I'm going to be very sad. Sad emoji. Okay? So I want you to talk to each other. Not just about sports or the weather. I want you to explain to each other how you're doing these calculations. Okay? Yep. Is that clear to everyone? Okay. So this is what I want to do. You'll have about 7 minutes to do this worksheet. I'll show you where it is in a second. If you get stuck collectively as a group, I really do want you to collectively put your heads together. But if you do get stuck, you can click and say, ask for help, and I will come into your room. Okay? So go to Questrom tools here. Let me show you what I'm going to ask you to get. Okay. Everyone see my screen now? It's got a web browser, Foxfire, Firefox, whatever it's called. So if you go into our section site, okay, so I'm in my section, our section, and if I click under resources, I'll see all these things, right? By the way, if I look down here, here's HP 10B1 executable file. So if you double click on that, it'll start the emulator. Here's what I want you to do. Go into worksheets. And if you go into worksheets, there's just one file in there. It's called Timeline Worksheet PDF. I want you to click on that and download it, okay? And then guess what? I want you to do it. Haha. Right? Everyone cool with that? I'm going to give you 7 minutes. Please talk, please work it out, and then come back. The idea here is I'm going to show you, here's the timeline, right? 4% is your interest rate, and this one says your aunt is going to give you 5 grand when you graduate in 4 years. So on your timeline, you might want to draw it on your timeline. What is the value today? What is the value when your aunt gives you the money in 4 years? What is the value 6 years from today? And then you have a different situation. Now your uncle is also going to give you 6,000 from your uncle in year 3 and 5,000 from your aunt in year 4. What's the combined value of both of those gifts today, 3 years from today? All we're doing is we're getting you to slide these values on your timeline. Okay. So, Professor, shut up and open up the breakout rooms. And we're going to have 8 breakout rooms. So there should be about 4 participants per room. Oliver, I'll ask you not to go into any of the rooms, and see you in 7 minutes. Are you guys not going into the room? You have to click on the room. You have to go into the room. Jan, who? Are you going into the room? You need to join the room. Victoria, are you in the room? Oliver, I don't know.
Yeah, I don't know why it's like not, it's like still showing them, but they're not there.
Yeah. All right, Catalina. Kate. Kate.
$4,274.020. You?
Yeah, that's
Okay.
what I got.
How are you, Oliver?
Pretty well. Early morning start for me, but wasn't too bad.
Yeah.
Did you have a good weekend?
Yeah, it was good. I went up to New Hampshire, so it's pretty good.
Relaxing.
Yeah, great weather up there. Apparently wasn't too good down in Boston, but it was great up there.
Yeah, the weather's been so hit or miss recently.
Yeah.
Oh, hello.
Hello, Damien, how are you?
I'm good, thank you.
Okay, are you working together?
We were just trying to fix. I mean, yes, we were working together,
Trying to fix stuff? Why, what was
making
broken?
sure our answers are the same.
What did you break? Oh. Okay, good. So are you near finished?
With the first part.
Okay, get moving on the second part.
Yep.
The present value of that plus the present value from the ant was 4274. So why don't you just add those two together for the first question?
Yeah, I think so.
That makes sense to me.
Yeah, me too.
Gia, right? Is that this making sense to you?
Hi.
Hi, you're
Yeah.
very quiet.
Oh no, we've been
'cause
talking now.
My
We're on.
calculator, I haven't get the calculator, so it's really hard for me to calculate it so fast.
Okay. Do you have do you have the emulator on your computer?
Yes, but it's hard to use, so
Okay.
I'm trying my best.
Okay. Josh, you okay?
Yeah. I'm doing the uncles section right now.
Oh, hold on. Hold your horses, baby. Joshy, baby. We're working together on this thing.
Yeah,
right?
we are. We are working together. We've
Okay.
been working together.
Okay. You don't need to do the next question. You can come back into class if you're done. But
Oh, wait.
Josh, use this as an opportunity. These are BU students.
Wait, I'm a little confused. Like we've been working together. We're
Okay.
on the second section right now, right?
Okay, I thought you said your uncle. Oh, sorry, your uncle. Okay, got it.
Yeah.
Sorry, I was thinking of the next question. Okay. Okay, keep going then.
Great.
Sorry, I'll leave you alone.
I think I just let me see. Okay, so gives the
Okay. What did you guys get for the uncles?
I said his was 5,333.98.
Yeah, I got the same number. Okay.
I'm gonna just use my answer from the timeline above because we already converted the 5,000
Yeah.
and added those.
Okay, you guys nearly done?
Yeah, we're almost done. Wait, wait, are we? Yeah. Yeah, we are. That's
Yeah.
last question.
Whoa. Yeah, whoa, yeah, whoa.
Wait, for the uncle, you guys got
I got 12,157.
Same, I got this.
7 for the last one. You got that one too.
12,157.17, sorry.
Yeah.
All right, we back? Is everyone back? Hopefully you guys didn't leave anyone back in the breakout room, did you? They'd be trapped in there for days. Okay, let's go. So this first one, your aunt, she gives you 5,000 in year 4. Who's going to help me go through that?
If I may,
Who's that?
I wrote it all down this time.
Well done, Alexander. You're learning here. Awesome. Okay.
So I got $4,274.02.
And how did you do that?
So I did it longhand rather than the calculator. So I did the present value is equal to 5,000 that you'll receive in 4 years, divided or discounted by the 4%, and then to the 4th power because you're waiting 4 years.
Okay. So you took 5,000, you divided it by 1.04, raised it to the power of 4 years.
Yeah.
Great. And you got 4,274. Right? Everyone in agreement? Okay, cool. Awesome. Do you want to just call out the next one? Oh, the next one is a tricky one. Alexander, what's the value when your aunt gives you the money in 4 years?
I just said 5,000.
Yeah, she gave it to you in 4 years, so in the 4th year, it is going to be worth 5,000. Okay. Yeah. And then the last one, what's the value 6 years from today?
The value is $5,000, $5,408. Sorry.
And how did you do that, Alex?
So if you get the money, or the value in 6 years is basically you get the money in the 4th year and then you wait 2 years with that money. So that's the same thing as the future value is equal to 5,000 times 1.04 to the 2nd power because you're waiting 2 years.
Right. So you compound it 2 years, you grow it by two years, and that gives you that. Perfect. All right, everyone okay with that? Any questions on that? Okay. Next up, Stephen, haven't heard from you yet today. That's it?
Hello.
Okay, let's go, baby.
All right.
Uncle gave you some money then.
So we already know the present value from the aunt. So now we need to find the present value of the uncle. And you just do 6,000 divided by 1.04 raised to the 3rd. You get 5,333.98. Add those two present values today together to get 9,608. Now to
Okay,
find the future.
So that was the first part of the question. Was the combined value of both of these gifts today, right? So you got 9,607. Let's call it.
No, 9,608.
Yep. Okay. So I got 9,607.
Okay, that's fine.
What's a dollar between friends, Stephen? Okay.
Not that much.
Never mind. Never mind. Never mind. Okay, it's what we call a rounding error in the business. Okay, next one. Then what did you do? Here's where the cool stuff comes. What did you do then, Stephen?
To find the future value, I just take the combined present value, times it by 1.04, raised to the third. I get 10,807.69.
Okay.
And then repeat the same process for, like, the equations are the same, just raised to a different n for the other two. And I got 11,240 and then 12,157.18.
Okay, great. Thank you. Did anyone do it differently or had a slightly different operation that they did on this? Well, first of all, let me ask you, did anyone use the top row of the calculator?
I did.
Okay, that's fine. So again, it's okay if you use the formula. As we go forward, I really want you to start using the functions on the calculator. Again, it'll help you in the exam in terms of speed, and also it's easy to fat finger something if you're raising it if you're doing a lot of operations. So sometimes it's easier to use the top row. Okay, cool. Did anyone do it differently in terms of, Stephen said, well, he brought everything back to time zero and then he slid it forwards depending on what the question was asking for. Another way of doing it would be like when it asks you what's the value, combined value 3 years from today. Another way of doing it would just say, well, the 6,000 is worth 6,000, and then the 5,000 you'll just discount it one period and then add it, right? Because I've discounted it now. It's at they're both at year 3, and now I can combine the value. And guess what? I'm going to get exactly what Stephen said, which is 10,808. Okay. Is everyone okay with that? So these are good practice to slide. So I call it sliding back and forward on the timeline, right? So just because I ask you the present value for something, I could also ask you, what's the present value 2 years from now? So, okay, so it doesn't need to be the present value as of time zero. It can be the present value 2 years from now. And that's, let's say, like if on the first question, if I had asked you, well, what's the present value of the 5,000 in year 2, I would just need to discount it 2 periods, right? And come up with the value, okay? Everyone okay with that? Okay, so the answers will be on Questrom Tools. Just the numerical answers, there won't be the calculations, so you can double check if you had any questions about that. Okay, let me go back and share my screen again. Okay, can everyone see my PowerPoint slide again? Okay, all right, so let's move on. I'm going to move on from that. Here's another question, but we'll skip over that in the interest of time. Okay, so valuing streams of cash flows. So up until this point, we've been talking about one discrete cash flow, right? And moving it backward and forward on the timeline. But usually projects and financial instruments, such as loans, are multiple cash flows, right? So we're going to say, well, how do we value multiple cash flows? All right, so here's the formulas that we have for present value and future value. But now we're going to say, okay, well, what if I have, I'm going to save $1,000 today. I'm going to save an additional $1,000 at the end of next year, and then an additional $1,000 at the end of 2 years, right? So in total, there's 3 cash flows there. If my interest rate is 10%, how much is it worth today? And how much would it be worth 3 years from today? Okay, so if I did that, this is my timeline, 1,000, 1,000, 1,000. And then I could do these operations, right? I could take 1,000, grow it by 10%, I get 1,100. Add it to the second 1,000 that I've added in, and I get 2,100. Then I grow that by 10%, and I get 2,310. I'll add it to the other 1,000, I get $3,310. And then lastly, I'll grow that by 10%, and that gives me 3,641, okay? That's one way of doing it. Another way of doing it is saying, okay, I'll just take 1,000, compounded 3 years, and I end up with that. I take 1,000, compounded 2 years, end up with that, then take the final 1,000, compounded 1 year, and I end up with 1,100. Add up those 3 numbers, combine them, they're all at the same point in time, I end up with 3,641. Exactly the same as what I had on the last page. Okay, so it doesn't matter which way you do it. Okay, then if I take it back to the present value, I will just do this, right? I will discount 1,001 period. I'll discount 1,002 periods, add those up, and I'll get 2,735. So what that's saying is, from an economic standpoint, I'm indifferent to actually getting 2,735 today, or getting 1,000, 1,000, and 1,000 spread out over the next 24 months, right? Economically, they're worth exactly the same given the interest rate of 10%. Okay. And then shouldn't be any surprise that 2,735, if I compounded 3 years, I get back to the 3,641. Okay, so all we're trying to say here is it doesn't matter at what point in time you want to look at this. Economically, as long as I use the interest rate, the number will change, but from an economic standpoint, $2,735 today is exactly the same as $3,641 3 years from now. Okay, everyone cool? Okay, all right, so let's do this then. So you've just graduated. We'll do this question. You guys can do it. Let's see, how are we fixed for time? Yeah, we have a couple of minutes to do this. Okay, so your rich Uncle Henry will lend you the money so long as you agree to pay him back, okay? So you want to buy a new car, you're going to borrow it from your rich Uncle Henry, and you offer to pay him an interest rate that he would otherwise get by putting his money into a savings account. And it says at the bottom, he's going to earn 6% per year on a savings account, okay? So the interest rate is 6%. Based on your earnings and living expenses, you think you'll be able to pay him $5,000 in 1 year and then $8,000 for each of the next 3 years at the end of the year, right? Okay, so that's the question. The question is, how much will you be able to borrow from your rich Uncle Henry given those data points? So so I want you to draw the timeline and then get the present value. And that'll tell you how much he's going to be able to borrow, okay? Draw the timeline, get the present value. Let's go from there. When you're finished, put your hand in the air. give you 4 minutes to do this. Okay, a couple more minutes. All right, let's do it. Goel?
Yeah.
Yeah, can you step us through it? What did you do?
So I didn't quite draw the timeline, but I could narrate it out. So
You drew it in your head, right?
Yeah, so for year 0, it'll be empty because we're finding the present value.
Okay.
For year 1, it'll be 5,000, 2, 8,000, 3, 8,000, and 4, 8,000.
Okay.
And to find the present value, I I did 5,000 divided by 1 plus r. That's 1.06. And I did it by 8,000 divided by 1.06 to the power 2.
Yep. And so on. And what did you get then at the end?
I got 24,890.665.
24,890. Okay. Everyone agree with that? Okay, cool. All right, so again, I know it's kind of, you might think it a little bit silly, but I would draw a timeline, even though you have good imagination in your head. I would draw, these are your cash flows. You're going to pay your uncle 5 grand, 8 grand, 8 grand, 8 grand. And then to get the present value, you do that calculus and you end up with 24,890. Okay, so that would be the amount that your uncle would be willing to pay to lend to you right now, today. Okay, then we're trying to say, okay, well, does your uncle end up at the same place? Well, here's what your uncle will do. Every time you give him 5,000, he's going to put it in the bank. Then you're going to give him 8,000. He's going to put that in the bank. That's going to grow. And then you're going to give him another 8,000. Put that in the bank. That's going to grow. And ultimately, he ends up with 31,423 in the bank. Okay. Or another way of saying that, the future value of 24,890, what he lent you originally, if he had just put that in the bank, it would have compounded 4 periods at 6%, and he would have ended up with $31,423, which is exactly what you're going to pay him on a future value basis. All right. So now we've just proven that economically your uncle is indifferent to giving you the loan today or putting the 24,890 in the bank. Because if you pay him on time those amounts, he will have the same amount on a present value basis and a future value basis. All right, everyone cool with that? Okay. Same value for your Uncle Henry. Great, good for him. Okay. Let's introduce this concept of net present value, right? So up until this point, we've said present value, but now we're going to say the net present value. And the net present value is just, well, what does net mean? All we're doing is we're adding the word net. And all that net does anyone want to tell me what a net does when you hear that term financially?
Is it like the net profit?
Yeah, but what does net mean?
It gets rid of it's after the costs. It's whatever you keep after costs.
Right, okay, so it includes the costs. So it's the revenues minus the costs. Or it's just everything added all together, right? So I'll take all the benefits and all the costs, get them in a present value basis, and then add them up, right? So my net present value is just the present value of any benefits minus the present value of any costs, okay? So you'll often hear people talk about NPV. This is what they're talking about, the net present value. So in this simple example, if you put in $500 today in the bank account, you'll receive $550 in 1 year. If the interest rate is 8% per year, the present value of the benefit is equal to $550, which I'm going to get, divided by 1.08 gives me 509. Well, I had to put $500 in to get that 509. So therefore, my net present value is the two of them subtracted. So it's $9.26. That's my net present value. The benefit, the present value of the benefit is 509. The present value of the cost is 500. Okay, net present value of $9.26. All right. Now okay, so that's kind of a goofy example, but now let's think of a more complex example. What if these were my cash flows, right? I had 25, 30, 25, 40, 10, blah, blah, 8 different cash flows, right? That's going to be a lot to calculate, right? So if I use the formula, it's going to be 0 plus 25 divided by 1.05, 30 divided by 1.05 raised to the second power, right? And so on and so forth. That's going to take a long time. Instead, what we're going to do is on our calculator, we're going to introduce this function called the CFJ function, right? So if you look at your calculators, I'll show you where it is. So here's my calculator. You will see here on the third row down in the center of your calculator, it says CFJ, okay? And all it is a cash flow. J means what's the term? It's from 0 to J, okay? So the way we'll do it is we'll enter in all the cash flows and just keep pressing CFJ successively. So let's see on this next page. Let's do this for Uncle Henry and that example. So I'm going to use the CFJ key, and my cash flows will be 0, then I press CFJ. 5,000, then I press CFJ. 8,000, then I press CFJ. 8,000, I press CFJ. 8,000, I press CFJ. So what it's doing is you're instructing the calculator that these are a series of cash flows, okay? Super important, super important, super important. Can you hear this? Super important. This 0 is super important. You have to tell the calculator assumes that cash flows start from today. So today on my timeline, if I go back to my Uncle Henry, my timeline says my cash flow, there wasn't a cash flow, i.e. the cash flow was 0, right? So 0 and then 5,000, okay? So if I put in those cash flows, then I've got to enter in the interest rate on the top row. So I'll put in 6%. Then I've got to say, well, what's my NPV? I'm going to press on the second row in red on my calculator. It says NPV on the second button from the right. Okay, so I'm going to do shift red and then that NPV button. And that's going to give me my my answer. Does anyone want me to do that on the calculator just quickly? Okay, CFJ is super important, so whether you want me to do it or not, I think I'll do it. Why don't I do it? Just for giggles, because that's the way I am. Here's my calculator. Everyone see my calculator again? Okay. Again, I'm starting a new calculation, so I want to clear my registers. So clear all. And I'm going to say, okay, first cash flow is 0 at time 0. So 0, and I press CFJ. Then I press 5,000, and I press CFJ. And you see, every time I press it, it'll tell me what number I've put in. So I just entered one number, so it said 1. Now I press 8,000, and I press CFJ. It flashes up and says, you've now registered something in the second period, and it's $8,000. Here's a shortcut, guys, that's important. If rather than keep entering 8,000, if I just press CFJ again, it's going to say, oh, you just want another 8,000. And then if I press it one more time, it's saying, oh, you just want another 8,000, right? So you don't need to keep entering 8,000. If as long as the number stays the same, just keep pressing CFJ, okay? So now I've told it all my cash flows. Last thing I need to do is tell it my interest. My interest is 6%. So I'll press 6 and interest rate. Now I need to get the NPV. That's the second row, second button from the right. It says NPV, so I do shift NPV, and it says 24,890 and 66 cents. Okay.
I have a question, Professor.
Yeah. Who's
So, it's Grace. So,
Okay,
does it
Grace.
matter if like the 8,000's negative or not? Like because you're paying this, it's an outflow.
Okay, so you're paying it. Okay, so if you put in all those numbers as negatives, what would be the total net present value, do you think, Grace?
It would probably be a positive number.
No, so let's do it. Let's do it quickly. So I clear my calculator again. 0 CFJ. Oops, sorry. Clear everything. Okay. 0 CFJ. 5,000. You said make that negative, right? Right, Grace?
Yeah.
Okay, so let's make that negative. So here, this plus minus sign, I just press it and it puts a negative in front of it. So that's the cash flow in year 1. And then 8,000, make that negative. That's the cash flow in year 2, year 3, year 4. 6% is my interest rate. And then I do shift NPV and see what I get, Grace?
Oh, it's a negative number.
Yeah, so because I put in all negatives, the net present value will be a negative number, right? And technically, yes, they are negative, right? Because I'm paying those, right? But we know the interpretation of that is your uncle will give you 24,000 and then you're going to pay him the 5,000, the 8,000, the 8,000, the 8,000. Is that clear? Okay.
Yes.
Everyone okay with that? Okay, CFJ
Hey, Professor?
Yeah?
So when we see negative numbers when calculating present value and future value using the top row, is that really just a convention and the values are truly positive?
Yeah, it's a convention, right?
I see.
But the whole point is you have to be consistent on how you're dealing with those cash flows, right? So if they're all going, if certain cash flows are going one direction, you can make those negative, but they all have to be negative, going that direction. And anything coming back to you, therefore, has to be a positive, right? So you just need to be consistent with your convention. Is that okay?
Yep.
Okay, cool. All right. All right. So I got a couple more slides and then we're done on this. Okay, I'm back to my calculator, my PowerPoint. Everyone see that? Yeah. All right. Calculator. So you're responsible to know how to use the calculator, right? So in an exam, please don't ask us, hey, I think my calculator is set to 155 periods per year. How do I change it back to 1 period? You think that has ever happened? You think someone's asked that? Oh yeah, they've asked that. They've also asked, how do I turn on my calculator? Never a good sign when you're going into an exam. But you can figure this out, right? Okay, so if you need to look at how to do certain functions on your calculator, there is a review also on Questrom tools. I'd encourage you to use it. Again, the faster you can use your calculator, the more efficient you are, the less pressure you have in an exam, okay? All right, so that is it for this class. Couple of things before we leave. So I will have office hours from 1 p.m. to 2 p.m. If you want to show up. I'm also going to stay on this call if you want to hang around at the end of class after people have signed off. I'm happy to talk after this class. Oliver, can I ask you what's for homework next week? Or next week on Thursday?
Yeah, you guys just have another My Finance lab that still due at 8 a.m.
Okay, cool. So keep doing that. The My Finance Lab guys, they're going to be the best. They're going to be really good to get your brain into this finance stuff. All right. Do them early. Don't wait. Okay. And the exam will be posted. The practice exam questions will be posted tonight. Do them as well so that you could potentially come to class on Thursday. We might have some extra time that we can go over some questions. All right. Any questions before we break up? Okay, I appreciate your attention today. I really do appreciate it when I see people nodding their heads and engaged. It really helps me a lot. So thank you so much for that. I look forward to seeing you on Thursday. If you want to hang around after class, that's cool. If not, peace out, baby. And I'll see you on Thursday. Take care. Bye.
Thank you, Professor.
Thank you, Professor.
Thank you.
Thank you.
Professor,
Yes.
I just had a quick question. For the practice exam problems, is there like an answer key that we can check it after?
I think so. But,
Okay.
but
It's
Julia,
at the end of every
but
document.
Julia, don't do that, right? So some people will just tend to go to the answers and not really.
No, I just wanted to use it like after I did them to make sure.
As far as I'm aware, there will be answers right at the bottom, or if not, if it's multiple choice, they'll highlight the correct answer.
Okay.
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 Yeah, we will give you the answers. But
Okay.
try do them. Have a good attempt first, and maybe fail a couple of times, and then look at the answers. Okay.
Okay. Sounds
Cool.
good.
Professor.
Yeah.
Grace. Yeah.
I had a question in regard to the exam. So would you say that the questions are more similar to the My Finance Lab or like the practice exam we'll have tonight?
The practice exam that you will have tonight are questions that either have been on prior exams or they're very similar to ones that you will have on the exam. My Finance Lab, to be quite honest, sometimes I find the English on it a bit trickier than, so they tend to be very nebulous concepts. The concepts that we will give you in the exam are, you bought something and then you sold it. They're going to be really practical type questions. But they're more, I think they're more directly worded, if that makes sense. Okay.
Okay, thank you.
Okay. Victoria, you had a question?
Yes, I just wanted to ask you for Oliver for the assistant thing, because I think I wasn't on the question tools yet for the classroom, so it wasn't recorded, I think.
Your
My-
attendance?
Yeah, the first day of class. I mean, it appears as unattended. No, unrecorded, I think, right now.
I'll add you into that.
Okay, thank you so much. That was it. Thank you.
Okay.
Bye.
Bye. Chia.
Professor, I have a question regarding the calculator app. It's like, why will sometimes like the answer is negative, but the number is right?
So
But
it's just how you interpret it. The calculator is programmed on the top row. You have to have one of the numbers be negative, right? So the idea is that if you invest your money, when you make an investment, you will pay the cash out, right? That's a negative. That's a negative number. But then when you get the return, when the cash comes back in and you make some profit, that's going to be a positive, right?
Yes.
So traditionally, that's the way cash flows work. It starts, there's a negative at the start, and then everything after that is positive, right? So therefore, if you put in all positive numbers on the top row, it automatically is going to give you a negative number, right? So the number is correct. You just need to interpret the negative. But it's it's obvious what the negative means, right? So in our example, I think that's what the last student that was asking in the classroom was, what if I put in negative 5,000, negative 8,000? If you did all those negatives, the present value would be positive. That means you're getting money from your uncle. That's a positive, right? It's a loan, but it's a positive number to you. And in return, you will pay 5,000. Then you pay 8,000. And then you pay 8,000. All those are negatives. Okay?
Okay. Thank you.
Okay, you're welcome.
Bye.
Bye. Gassan?
I just wanted to ask a personal question. When did you work for Schlumberger?
Schlumberger, I worked in 1990. 1990 to 1993, I think, thereabouts.
Oh, okay. It's a long time ago.
Yeah, it's a long time ago.
Yeah,
Why?
because my parents used to work for Schlumberger, so but it was more recent.
Oh yeah, where did they work?
Middle East and North Africa. My mom was legal counsel for Middle East, North Africa, and Turkey.
Oh wow. Oh,
Yeah.
cool.
But just want to see if you knew them. Maybe, but probably not.
No, probably not. No.
Yeah.
Great company though.
Yeah.
I loved it.
Yeah, their stock is doing better now than it was before.
Oh yeah. Well, all oil company stocks have been beaten up.
Yeah. All right. That's it.
Okay. Take
Bye.
care. Bye bye.
Bye.
Xiao Yi. Hey, can you take yourself off mute?
Hi, sorry. I had a question regarding the calculator.
Yeah.
I actually figured everything out on this calculator, the one
Okay.
that I emailed you about, because my new one isn't gonna get here like until past exam one. And
Okay.
then for like the app, I tried it, it works, but I feel like it's better to have like a physical one. Am I allowed to use this on the exam one by
Sure.
chance?
Sure.
Thank you. And so like Savannah, the problem she was having with this calculator, I like looked at the manual and stuff. I figured it out. Other than the very last key you introduced us to, the CF key,
Yeah.
this is what it says. I'm very sorry, but like this is what it says.
Yeah.
However, every time I enter, like it's like I enter 0, I press CF. It's not J, but it's CF.
Yeah.
So I press 0, press CF, and then 5,000 CF. Like it's always CF0, like CFO. Is that like the initial value? Like it wouldn't change to CF1 or CF2 for some reason.
It should do. Again, I'm not sure about that.
I'll maybe look into it.
I think if you look on the manual, I mean that's a great resource. It should mention it, or if you look it up on Google, I'm sure you'll get the answer really quickly.
Yeah, it has a lot of worksheets like cash flow, bond, loan stuff.
Yeah, we're going to be doing all that good stuff. It's going to be don't be scared. It's going to be so much fun.
Okay, got it. And also, quick question would be, you know how you're gonna release the exam practice question tonight? Is it gonna cover the stuff we cover this Thursday before
Yeah.
exam?
Yes.
Okay, all right.
Yeah.
Is it a huge chunk of new information that I'm not gonna be able to finish the exam without knowing?
No.
Okay.
No. It's going to be it'll be more about on the top row of our calculator, right? Usually we'll solve for the present value or the future value, but you know what? You can also solve for the number of years, right?
Yes.
So we'll just go over that, how you can use your calculator to solve the number of years, interest rate, etc.
Okay.
Okay.
I see. I think I have one more question. Oh, okay. So how long are the exams? An hour, right? How many questions again?
Yeah, so they're about an hour, and I think it's about 22 to 24 questions.
Okay, got it. Yeah, because
I
I'm
haven't seen the final one, but
yeah.
Okay.
Yeah, thank you.
Okay, see ya.
Mm.
Bye. Oliver. Yeah, we're all good. You all set, baby?
Yeah.
Okay. Thanks for showing up today.
Yeah, of course.
See ya. Go out and bye.